everyone. Now, we will be discussing about a topic in forensic odontology, which is digital forensic dentistry. I am Dr. Sohan Srivastava. We will be covering digital dental records and various digital aspects of forensic odontology, forensic tools which were utilized in traditional methods when they are digitized or computer assisted. We will talk about these, including the optical scanners intraorally, with computerized facial reconstruction tools, autopsy, three-dimensional printing, etc. Now, digital forensics can be defined as application of computer science and investigative procedures for a legal purpose involving the analysis of digital evidence. Digital forensics has replaced the traditional forensic investigation in terms of acquisition, analysis, and reporting of forensic evidence. The computers are used for committing cybercrime, and hence the digital evidence forensics and the law enforcement agencies are now using computers to fight this type of crime. Now, when we talk about the tools in digital forensic dentistry, the first thing which comes into mind is the digital dental records. It is a new style of dental charting which has been introduced that is constructed using actual oral digital images and the dental data, which is easy to upload on the internet website. It provides a large volume of information and reproduces the dental conditions very clearly, in detail, on a cost-effective basis. The computerized software, it enables a rapid comparison of the ante-mortem and the post-mortem records of the deceased victims in cases of mass disasters, earthquakes, terrorism, etc. In addition, the software also allows superimposition and comparison of the digital radiographs and the photographs of the deceased person. Then we talk about some digital forensic radiography, which is utilizing a handheld radiographic machine or a radiographic machine with a sensor. The digital radiography is highly advantageous as it allows immediate display of images on the computer screen. Now, these images can be enhanced for optimal viewing, and side-to-side comparison of ante-mortem and the post-mortem radiographs is also possible with an improved image quality, and this accelerates the process of identification. The post-mortem scanning time, it is reduced by utilizing some advanced imaging modalities like MDCT, multi-slide CT, or three-dimensional scan beam CT, data scan, etc. And these modalities, they have the capability to clearly differentiate enamel, dentine, alveolar bone, and the restorations. Now, talking about digital photography, it is the best method to collect, preserve evidence, especially in cases of abuse and bite mark analysis. Now, the digital cameras, they are used to get computerized image files. These can be transferred to the computer and displayed, edited, emailed, or printed as we wish. Now, some visible light photography. It is the most common method for documentation of bite marks and a photographic image. Over here, the visible light, it exhibits four phenomena: reflection, absorption, fluorescence, and diffusion. And the captioned image, it displays a combination of these phenomena. Recently, a non-visible photography has been introduced, which utilizes the infrared and the UV light. It enhances the appearance of injury in cases of distortion of skin. It records the details of the bite mark injury of the skin that appears completely healed under visible light. So, it is of utmost importance when we utilize the infrared and the UV lights. Then we see the intraoral three-dimensional optical scanners, which utilize certain these laser lights for scanning the dental arches and the tissues. The direct and the indirect scanning of the dental arch by the use of internal scanners has significantly improved the accuracy of bite mark impressions. Instrumental 3D scanners may have included the use of impression trace and the material, which usually result in patient discomfort. And these also provide reliable, rapid, and non-invasive analysis of the bite mark evidence. Then, computer-assisted overlays in bite mark analysis. And the comparison of the suspect's dentition to a bite mark injury using overlays. It is the traditional method where hand-traced or photocopied bite marks are made and tracings are done, and overlay is done to see and compare whether it is the same person or not. The recently computer-assisted overlay generation method is seen to be more reliable and accurate in comparison to other methods, which also results in a lot of observer bias. Recently, a new software has also been introduced, Dental Print, which generates comparison overlays for 3D images of the suspect's dental cast. These overlays are more accurate and it's difficult to manipulate the 3D images by the third person. Now, the computer-assisted dental identification softwares. Computer-assisted post-mortem identification, or CAPI. This program has been assisting forensic odontologists in identifying victims of mass disasters by producing possible matches. The DVI, Disaster Victim Identification System International, it has an advantage of simultaneous display of comparable antemortem and postmortem pages in the same window as part of Microsoft Office Word function, and the display of digital photos and radiographs, which can be done as a part of Microsoft Office Picture Manager function in this software. The latest software is the WinID3. This application was used in various mass disasters like terrorist attack on the World Trade Center, in hurricanes like the Katrina, etc. This uses an intuitive algorithm that gives it the ability not only to sort for the requested identifiers but to compensate and not eliminate the identifiers. Changes that have occurred due to reasonable and explainable differences in the references. That means if there is a time frame between two references or two identifiers, two point of objects, then that change is also taken into account and the object is not eliminated, which is taken for comparison. Computerized facial reconstruction. Facial reconstruction, it is a forensic tool that involves recognition of a skull accidentally found in a forest or mass disaster for positive identification of an individual. There are some software advancements have led to the development of computerized 3D facial reconstruction systems to recreate characteristic facial morphology dependent on the skeletal features. The skull is first digitized using a laser scanner and a video camera interface to a computer, forming a fully shaded 3D surface. Computerized systems are more rapid, easy, efficient, and cost-effective than manual reconstruction methods. It decreases practitioner subjectivity and skill, recreates multiple images of the same face efficiently, and provides realistic facial appearances, simulating the photographs. Then we see autopsy or virtual autopsy. Progress in imagistic modalities or imaging modalities has changed the face of conventional autopsies into a scalpel-free autopsy, virtual autopsy or autopsy. Advanced modalities like CT or MRI scan the dead bodies and provide more sensitive, specific, and accurate results than that of conventional autopsy. Autopsy is accomplished by placement of markers on the surface of the body by the help of vertibot. Magnetic resonance spectroscopy is a recent technique in autopsy that determines the relative concentration of various metabolites in the tissues, thus useful in estimating the time of death. MR microscopy is a microimaging technique which is used to study the soft tissue injuries like retinal hemorrhage, electric injuries to the skin, etc. Microtomography is used to study the weapon involved in its injury patterns. Then we come to three-dimensional printing. In the digital world, the use of 3D printing in investigative or code purposes is relatively unusual. It has taken forensic investigations to a new level that quickly generates the physical replica of an object from the computerized data. 3D images are commonly used for 3D printing due to relative ease of image post-processing. 3D printing has wide forensic applications including bite mark analysis, parotoscopy, chondroscopy, tongue, print and pattern analysis, facial reconstruction, sex determination, age determination, districts, pattern of homology. They are very helpful in solving crime cases and presentation of evidence in the court. Forensic comparison microscopes. They consist of two compound microscopes that are placed side to side and allow forensic experts to view both the samples together the center eyepiece. It employs a digital camera system to view and simultaneously compare both the images to see whether they are identical or different. Then forensic biorobots. Barry's project found biorobot M40 to be very effective for DNA extractions from most specimens in forensic laboratories. They have helped laboratories for automation of DNA sampling process, which involves extraction, quantification, and dilution. These primarily aim at improving the efficiency and enable the forensic scientist to focus on analysis and interpretation rather than on the processing tasks. To conclude with this topic, we may say that advancements in the technology have opened up new directions to solve criminal and civil cases, and digital forensics has revolutionized the traditional forensic investigations in terms of collection and the analysis of data. In the coming years, digital forensics will become an integral part of forensic investigative process, and the reduced cost of technology will enhance the utilization by various specialities. Thank you for your patient hearing, and queries can be given at my email ID, and your assignments will be posted to you. Thank you.